my name is Terje Kvernes, and I've been doing some mostly trying to organize the infrastructure of a project that had, let's call it what it was. It's been a moving target. We've realized we needed stuff on the fly, and we've been constantly kind of rearranging how we do things and what we need in the future and what we realized was a bad idea. So this is going to be both a look at what we have done, what we currently are running, and what we should be doing, and possibly what we can learn to do that better. And I also like to tell anyone who's concerned that this is actually pinkish purple. It is not gray. So I'm sorry, the pink is really coming out today. Anyway, today we are currently running in 5 locations. There are some small extra bits here, but this is the public sphere that people think of when we say EESSI. Both the Frankfurt and Dublin sites are AWS sites. The Virginia site in the US is on Azure. We are using some physical hardware, I think, in Groningen, and some virtual machines. And we have some OpenStack and other things running in Bergen, Norway. The good news is that this means that we have actually 4 Stratum 1s in production right now. Well, production in the test file, the pilot phase. The downside is that the map isn't exactly global. I mean, you can probably drive between 3 of these Stratum 1s pretty easily if it wasn't for this thing called an ocean. The upside is that we do have multiple providers. We have multiple backend types. I mean, we're not all just running on AWS. We're not all running on Azure. We support a lot of things, and some of it is better supported than others. That's also something we badly need to work with. We're provisioning hardware, machines on hardware, semi-automatically. I'm going to go back to a little bit of how much of this is done script-wise, how much is done purely automatic, and how much is actually still done manually. The tool of choice is Terraform, pretty much the only realistic option when you're dealing with multiple providers and multiple types of backends. We use primarily to deploy nodes into AWS and to some extent Azure, but that's still in the testing phase. The code base can be modularized and reusable. It currently is a hodgepodge of things to make things work and lessons learned. The upside is that we do already have a deployment system using Atlantis, which is a GitOps-based tool where you essentially commit changes to your Terraform infrastructure, and Atlantis picks up the changes depending on whether or not they get merged and whether or not they are in as a pull request or whatnot, and applies tests to them and tries to make sure this will actually work out. This has basically been the biggest change we have done when it comes to the provisioning code for a long time, was actually make it somewhat more transparent like that. I'm going to come back to that bit as well as how infrastructure as code, which is what Terraform does, in its own right isn't enough. Also, Terraform is provider agnostic on a conceptual level. The problem is that each provider has such specific ways of dealing with everything from images to networking to basically anything you can think of, that the code for running things in Azure, the code for running things in AWS, and the code for running things on OpenStack are fairly different. You abstract that away, sure, through modules and whatnot, but exactly how provider agnostic are you? You still end up having to recode stuff for the different platforms to make sure that you actually do things correctly. That's provisioning. Once you provision something, you want to configure it. And we are currently using Ansible to do that job. which is nice. I mean, it's YAML, it's readable if you try hard. As with Terraform, it's very active. There's a big community. There's a huge ecosystem of both modules and extensions and whatever you need to it. But from our perspective, we have seen the issues that sure things change and we have to change with it, but we also have a very distributed solution where different repositories hold different playbooks for different purposes, and figuring out what you need for your job is not always easy. It's actually sometimes quite difficult. Just something as trivial as setting up a client, which repository do you think that's in? Is it in the component layer, software layer? We don't have a client layer. Where do you find that playbook and how do you run it? There's documentation for all of this, but it feels like it's documentation to counter a lot of the structure we have, rather than actually being a tool for telling you why this is smart. If you have any questions, please feel free to ask them as we go along here. The model in Ansible is that you have inventories that tell you what nodes you have. You have roles assigned to these bits that are essentially what is the purpose of this node. And as you might be able to make out on the right-hand side there, you have a role that is a proxy server, and it has some variables. And then the client configuration for a fictitious site, you set up what proxy service to connect to, and you can then reference the same data, and you can link things together, and you can end up in a structure where it's very, very little code to do a lot of work. This entire restructuring of the Ansible environment is something we've been doing for a very long time, and it's been very hard to get just so, also because we depend on a lot of external things like CVMFS and how to deploy monitoring and things like that. But that's definitely something that is very, very close to being, well, I think it's actually ready. I think it's more Bob and I have to test a few last bits of it and make sure it actually looks pretty and is usable. Today, all of these things are done in separate environments, so it's a lot more fiddly to actually configure, especially on scale. I mean, it's easier to configure a Stratum 1. It's harder to keep all the Stratum 1s synced with the correct configurations and correct everything else that's needed. So when we went about working on EESSI, there should have been a planning phase. I think that was very much a let's get something up and running and see what we can do, which was a very loose definition of planning. And that didn't actually end up going anywhere in a constructive way. But what we should be doing is thinking of what actually is the design goal here. We should also be able to do cost-benefit analysis, and we should be able to do cost estimates on what we look at deploying. Today, that is not something we do in advance. It's something that happens afterwards when we get reports from the different environments we use. Then we provision what we have seen as a need. In the current environment, we test against the test environment directly, which means that you can either test it locally on your machine, or you can push it to GitHub and have Atlantis do the testing for you. The scary thing is always that, let's say you want to make changes to the production environment. How do you do that in a way that's actually is safe or feels safe? Because if you run Terraform locally to test something just to see if the plan works, just to see what would you do, you are almost guaranteed, if you do things correctly, that you're testing against the current environment that exists, making sure you use Terraform correctly locally. Or if you push it to GitHub and you have other people look at it, you still need to have Atlantis plan what it's doing and then hopefully apply it if it's correct, as the terminology is in Terraform. This feels very, it's a little bit of a spooky environment because there's not a lot of logging and traceability even though you see it in GitHub and their output from Terraform, there are other things you would like to see better. We're going to look at some of the solutions for doing this with a little bit more oversight. We're going to get to that at the lessons learned later. Eventually, if everything looks fine, the plan looks safe, everything like that, you approve it, and you merge a branch. Atlantis applies the changes, and it propagates that through the environment. Once that is done, we need to make sure that something like the Ansible inventory that tells you what nodes exist. What if you created a new node? It's now part of it now to become part of the inventory that is being pushed configuration towards. Currently, that's a manual task, which is not ideal. That needs to be also looked at how we do that. Once everything is, you have a provisioned hardware or provisioned nodes, you have made the inventory correct, you then push configuration to the nodes and to the inventory, and hopefully that works. Long-term goal here is listed as having a master deployment node, but again, that's possibly not what we want. There are ways to do this better. I'm going to use the word better. I'm not sure better applies, but there's a way of doing this in a more functional way, I hope. And when all of this is done, hopefully you have deployed nodes, you have pushed configuration to them, they started running services, and these services are then picked up by the monitoring system to actually have an overview of what's now supposed to be tested. This is, again, currently manually done because we don't have any good inventory tracking and role tracking across all of the EESSI stack. Now, we're going to look a little bit about what we actually have in EESSI. What's actually, when we talk about infrastructure, what do we actually mean? I know you've all seen these things before, at least the first bits of them, so I'm going to go through them pretty quickly. We have a Stratum 0, which is a unique thing that is singular, that has the main repo and everything. So I think that's only partially configured by Ansible. We can do it. There are people who have, but that's still a bit manual. Stratum 1, we have many of those. 2 of them are mostly configured, or 3 actually now, are mostly configured via Ansible, but they're not actually wholly there yet. And they're mostly provisioned via Terraform, because the ones in Azure is, the one in AWS is, the one in Azure is not, because it was before we had Azure support for our Terraform infrastructure. And the one on OpenStack is also configured by Terraform, but not from EESSI, but from the Norwegian EESSI project that hosted. That means the configuration is a little bit all over the place again. The same applies to proxies. Some are configured for testing. We don't run any public proxies at the moment, so that's not really much of an issue right now. But again, the configurations there do change a bit. And yet again, for clients, the same applies. You can configure them by Ansible, but most people who set up their clients probably do this a little bit more manually. You should offer something a little bit easier to deal with there. Now, for the stuff that isn't talked about a lot, and the other stuff that people don't see that is a part of the infrastructure itself, we have the monitoring environment. It runs Prometheus plus Grafana. We have Atlantis for the deployment. It runs as a self-hosted service right now. That's for the Terraform deployment. We have a login node with some local persistent storage, because the login node has the correct, well, the login node has access rights to the S3 buckets that we use for tarball uploading. So if you have access to the login node, you don't need a personal token to be able to upload. We have a status page that shows basically the status of the EESSI stack. I skipped S3 buckets. We have S3 buckets, as I said, for compatibility layer data. We have for some software layer tarballs. We have some interaction with certain GitHub tools. We have logging buckets, and we just have a lot of buckets. Very handy, very useful, but they need to be configured and they need to be set up with access restrictions and they need to be set up with things like history and what happens when things get old. We also have ephemeral nodes, like the things that people were offered yesterday. But beyond that, we have more things that people tend not to think about. We talk to identity providers. How do I know who's who? How do I know? Yeah, sure, I want to give access to Kenneth, but how do I know who Kenneth is? How do I verify his identity, and how do I ensure that when he asks for permission somewhere, either through like direct means or machine-wise, that he's actually Kenneth? And not to mention, we have an insane amount of access control that we have configured that people never see. This is things like, what hosts do we have? Who can access them? Where can it be accessed from? What services do they run? Where can these services be accessed from? Are they available to the public? What networks do they hang on? Do these networks talk together? Is there a local network? Is it a global network? Is it a specific GRE tunneled network? What users do we have? What roles do these users have? What groups do they belong to? This is all part of the infrastructure. People tend not to think about it one way or the other. It's just assumed that it'll work, but it really doesn't. So this is part of what we need to look at. And we have some of this today. We have a lot of this today, actually. But again, it's a slightly different scale than the pilot phase for having this in production. We're going to look at details of some of these aspects now, like the S3 buckets. Completely and totally provisioned and controlled from Terraform. This includes access lists, tokens, everything like that. And we currently run the S3 buckets on AWS, but that can theoretically be moved. There's also a ton of lifecycle management. Things like when tarballs are older than so old, they go into slightly colder storage. Saves us money and also means that we can have more data for cheaper. When they get really old, they go into Glacier, which is, it takes time to find the tarball again, but it's nearly free to keep it. And once it gets over a certain age, it gets expunged. And the great thing is that this is automated. This is not something we have to deal with, but we can go back and say, oh yeah, we had a compat layer update in 7 months ago. That tarball is still available. We can still fetch the data. We can still retrieve it, even if we have deleted it, even if we didn't publish it, but somebody fetched it or something. We can track this stuff up until at this point for 360 days. And of course, also all the access lists, as I said, for the buckets are terraformed. Kenneth wanted also to remind me that we do have a cluster in the cloud set up. This is very neat, but it's also worth noting from an infrastructure point of view. This is completely a closed box. There's no access control. It's not terraformed. It's spun up fairly manually by Kenneth. And access control is what we need Kenneth for that. So when he's on holiday, it's a little awkward. It is, again, one of those things where you see, oh yes, this is a brilliant idea, but we need a little bit more of wrapping around it to make sure that it actually is manageable on a level that is closer to what the project needs and not just what we need as individuals here and now. We have a status page that shows the status of EESSI from a user perspective. It's built around a scraper that I've written that basically goes out to stratum 0s and stratum 1s, looks at some public metadata, and some other things we've gotten added from the CMFS group. We've developed patches for them to actually give some more data specifically to make the scraping more useful. It reports on things like the stratum servers, their state in general, the status for all the repositories they host. Are they synced with stratum 0 in a correct way, or are they drifting? It's a very handy tool. Unfortunately, the provisioning is fully automated. the problem is that the configuration right now is manual. And it's not too hard to make an Ansible role for this. It's just, we have it, it's working, and time has gone other places. It's also, let's face it, it's fairly almost all the entire environment around monitoring and scraping is literally scraping. That means that it runs every so often, currently every 2 minutes, and goes out, finds data, hope that it reports back, and that's your granularity. There's no events, there's nothing like that, which has both upsides and downsides. The same scraping tool is used for our Grafana front end with this Prometheus backend. Prometheus does the time series, so it keeps track of the history. The Grafana is what displays the, graphs. It has essentially a historic view of all the data, and a lot more actually than what you see in the status page. So it can tell you not just there is drift, but when did the drift occur? Theoretically, we found some issues with that as well. Fun fact, when the stratum 0 goes down, it's very hard for the scraper to compare available versions between stratum 1 and stratum 0. So the scraper died. Not ideal. Lessons learned. The entire configuration of the monitoring node is pretty much manual, but both Grafana and Prometheus have very good tools for automating deployment. So we're looking at doing just that. Again, time is the constraint. Also, it currently only monitors the production environment and the production nodes that is specifically fed. So if you add a stratum 1, you have to manually add it to an inventory and manually add it to a inventory for the scraper for the monitoring node. This is, not how we want things to be done, but it's shown that it's actually doable to at least get things up and running. That is a lot of what we have today. Are there any questions about the state of EESSI today?
Hi, this is Hugo. Thank you very much. Looks really awesome, and I've been enjoying the services you have been providing so far. So that's really great. One question. All the Stratus 1 servers are currently, as far as I understand, are currently VMs basically serving HTTP on the front end.
Yep.
I've been playing around with CVMFS itself and working on sort of like the S3 interface to allow either S3 or some alternative blob mechanisms to support CVMFS directly, sort of like making sure that sort of like the handling of the VM isn't required anymore. Is that an option moving forward, or are there any sort of like useful?
We looked at using S3 as a CVMFS backend, and there is absolutely no problem doing this. We don't have any easy rules or any deployment environment to produce that right now. There are some interesting issues with it. First of all, the upside is you get global coverage from S3 for free with CloudFront. Is it? Yeah, I think it's CloudFront. Pushing the stuff from AWS. The downside is that we suddenly have to pay for every byte that leaves AWS, and if everything is accessible via geolocation from AWS, a lot of nodes are going to start using AWS rather than our other stratum 1s, which is a financial thing we have to think about. So, but I mean, there's nothing wrong about it at all. It's definitely something we want to look at, but there has been concern about the cost.
Any other questions in the room? Nothing here right now, Terry. I know you can't see us. You can see us.
I can see you, kind of. Okay, let's move to plans. There's something called the future. We're hoping to actually move into that at some point, but it's infrastructure code, so we'll see what's happening. We're gonna look at some current plans first. First, for the Stratum servers, we're looking at a physical Stratum 0 using a YubiKey for signing keys that are rotated regularly. So have a little bit of extra security. I know there are people who probably sit there and say, oh, yes, you can use a YubiKey in VMware and you can have a USB switcher that moves the YubiKey between, the physical machines as the virtual machine is being transferred. Yes, you can. No, not doing that. There is the issue with access rights to Stratum servers. We're looking at making that based on GitHub Teams. That's one option. That's something we have looked at, and we have code that does that right now, so that we can maintain access in a functioning way. Like you can invite people to a GitHub team, and they then get access to the correct infrastructure. There are plenty of options in this field, both with regards to the identity provider, whether or not GitHub is a good one to use. The thing is just that GitHub is already baked into the way the entire workflow goes. I mean, theoretically, you can replace it with GitLab. Sure, that's not really the biggest problem here, but the GitOps environment is fundamental to how things are done. So using that as an identity provider, since it's already there, is extremely tempting. We've also looked at how we produce images for the operating system that we deploy. Currently, we're building specific images, not just for the Stratum ones, but like general images and more specific, and looking at using Packer to kind of pre-prep images for deployment. Packer supports pretty much everything you want to throw at it, whether it's AWS, Azure, OpenStack, or whatnot. The downside is that you do end up having to maintain a lot more of a strict workflow of how something is deployed. I mean, the deployment then has to use your image basically, which is fine as long as it's us and our Stratum ones and our proxies. But if we're going to provide somebody with an announceable playbook to say, hey, here's how we set up a Stratum one, if they don't have access to our image, our playbooks already have to take that into account, at which point, why do we even deploy the image? We're just duplicating work. So that's the way we're doing this has to be considered. We're also looking at making the Stratum setup a little bit more global and not just, centered around Groningen, charming as it is. And of course, the automated monitoring needs to be fixed from the Stratum servers so that once you add a Stratum server, it automatically gets monitored. We have some other bits as well. We're moving to EESSI IO as our primary domain. That will involve a lot of restructuring. Fortunately, from a Terraform point of view, it's very easy to migrate DNS. That's not really an issue, but it's still things that need to be dealt with. One of the frustrating things is now that we're moving towards maybe looking at GitHub as the identity provider. Sure, we have, for some services, the way to get this for free. We can do it over SSH and pull keys and do login checks, but we need to do, what if you want to have access to Grafana? That's not going to happen with this SSH key. Where do you get the username and password for? Does the Grafana server even have access to the internet to the point where it can use GitHub as a login tool if we had it? Not sure. Same happens for Atlantis. The management interface there, who gets access and how? Where are these passwords stored? We could set up something like HashiCorp Vault to keep these secrets safe and have them be available to people. But again, how do you get access to Vault? This is easier in a formal organization where everybody has their own identity, where we have a local identity provider that has an idea of who everybody in the team is and who everybody in the project is, and these kind of structures are then propagated out to GitHub or out to Atlantis or out to the monitoring tool, either via LDAP or something similar. But yeah, we need to think about this, and it's not something that's clear to me what a good solution for us is. It depends also a lot on how the project becomes structured long term. We have had a desire for a dedicated management node or nodes. We probably want one in Azure and one in AWS if we do this, that has access to the relevant infrastructure. The question is, again, long term, yes, we should probably have this. We need it for just in case and back and security and whatnot, but ideally, we're not going to be deploying things from a management node. We're going to deploy through some sort of automated tools based on Git. So this should be a check what's going on and why it's not working thing, not something you use to actually deploy playbooks or perform things like create even ephemeral nodes. They should all be moved to Git. But this means that if we're doing this, we need better EESSI, interesting order, pipelining for playbooks. We need to make sure that when you actually make changes in a playbook, that it's actually deployed to the correct nodes in the correct fashion automatically, rather than expecting somebody to log into a node and deploy them. This also involves, again, we need to look back at the security aspect and access restrictions, who has access and how. We badly need somewhere to centralize critical metadata. What are the public stratum ones? What's the authoritative inventory list for EESSI at all times? Today we have many inventory lists, and none of them are actually really authoritative. They're used in different places for different tools, and that's awful. And of course, we need to look at the infrastructure code, clean it up thoroughly, and possibly wipe and start over. We're going to look at some of the lessons and the challenges that they've given us. I know we're running a little late, Kenneth, but yeah. So the current challenges. The code base itself, using Terraform and Ansible, have a lot of charm. There are many ways of doing things. This is sometimes a good thing, not always. There are best practices for both tools. We try to follow them, but it's really hard sometimes, because sometimes your problem just doesn't fit into one of the buckets that either tool suggests you use, and then you end up drifting, and before you know it, it's awful. So you won't always follow the best practices, but you can bleeping try, and we're going to be better about trying. Versions change both with regards to the tools, both Ansible and Terraform, but also the providers themselves change things, and the code needs to change with it. I have in my life probably never seen anything that rots as quickly when it comes to code as infrastructure code. Things that worked 6 months ago probably have issues in some form or another today. It's the nature of the beast. When it comes to monitoring, yeah, sure, monitoring is, we need to automate a lot of stuff, but there's a bigger problem, and that's alerting. How do we alert? When do we alert? Who do we alert? And where do we push all these alerts when we actually have them? Today, we have some stuff, but it's very ad hoc, and it's not scalable at all beyond like people in the know, and that's awful. This is a problem I know that people have been dealing with for 20 odd years, and it hasn't gotten any easier. I mean, but we need to decide on how to do this going forward. We have challenges with regard to testing. We need a full-scale testing environment, certainly. That doesn't exist properly today. Stratum 1s are hard to test, because proper testing Stratum 1 means cloning a large chunk of data, because you want to have the full repo if you want to have a proper test of it. Which means that, again, if there's a financial and a logistical cost of doing the complete mirroring of the production environment. And even so, it's not going to be perfect, because you have different IPs, you have different environments, you have different VPCs, you have different things are different. It's really effing hard to make it be perfect. And what do you do with regard to things like login nodes, management infrastructure, and log buckets? Think of it this way. Let's say we have a testing log bucket. That logs all the stuff that happens. It's a testing environment. The problem is the testing environment is volatile. You nuke the entire crap out of it sometimes and rebuild it. You lose the logs. Right, okay. Maybe you have all the logs cloned to the production environment, but then the production environment, the test bucket for the production environment, not only needs to have an understanding that there is testing logs in your other data and have some way of separating them, okay, but you also need access rights for the testing environment to put logs into this data, and you need to make sure that it's not doing anything bad and pretending to be production or in any other way compromising the production logs. It's not an easy problem to actually solve. There's no pretty way of doing this. There are plenty of solutions, but we need to pick something, document it, and live with it. There's a design choice that's problematic as well. We need multi-provider redundancy. We don't want to be reliant on AWS or Azure or anybody in particular. We don't want a single provider to be the end-all be-all of easy. Infrastructure as code, I'm not even going to try, is nice, but it's not enough. It's not enough that the infrastructure is coded if you can't be certain that the code is what's actually running. You need deployment and configuration, everything to be guaranteed from the environment you actually produce it in. It's way too easy today to run Terraform on your laptop or Ansible on your laptop and deploy to nodes or deploy new nodes, and this does not get reflected in any of the other like CI/CD pipelines we do actually have. But the hardware is there. Hardware stuff, the virtual machines and whatever is there. And today, lots of configuration is automated, but as we pointed out, even if it's scripted, it isn't actually automated. It's the scripts that run semi-manually, but they're not deployed on change. You change the Ansible's script to a playbook to actually deal with Stratum 1s, to deal with things like, say, keys or any other things that they need to get updated now and then. This is automatically deployed to all Stratum 1s. You fix the Ansible playbook, but again, it's not deployed. So I'm proposing that we move further and further into the world of GitOps, where everything like this is done in, say, GitHub or GitLab, where every time you do a merge or you approve something and then you merge it and then it gets deployed. And this is automated, it's documented, and it's a hard rule of this is the only way to deploy anything ever. There are no other options. For provisioning, using Terraform, we're probably going to look at Atlantis and or Terraform Cloud, possibly using GitHub Actions to hook things together a bit. There's plenty of ways of doing this. We should do this probably with a fairly clean slate, and we need to think of how we structure repos for it. One downside is that Terraform can run random shell commands, or not random, but anything you feed it. So infrastructure repos that allow you to run Terraform code, even from a testing phase, like for planning something, probably needs to be restricted access to prevent people from being able to do things like run a shell script on the node that is supposed to be deploying stuff. There are, again, ways of trying to get around this, but it's security in that regard is really, really hard to get right. For Ansible, we're probably looking at GitHub Actions, Semaphore, or something like Rundeck. If half the audience were sysadmins, they probably heard Rundeck and then moved, so I'm guessing most of you people aren't. And of course, the other issue is if you run any of these services self-hosted rather than as a cloud service of any kind, we need load balancers in front of the service to make sure that if, say, Atlantis goes down on one of our Azure nodes, that the AWS node running Atlantis still receives the event and does its job. There is there's an amount of yak shaving here, but before you get to deploy something, you have to do 9 million things before you get to this point. Having to deploy load balancers to implement a service, so the service can listen to GitHub events, so the GitHub events can do deployment, because you wanted to create a temporary node for somebody. Yeah, there are things to think about. Now I'm going to finish up with some of the lessons and some of the things that we've gone through today. Infrastructure is a living thing. it is not, you're not done with it. It's never complete. It just keeps on wanting stuff. And automation isn't, because no matter how much you automate something, as Bob and Kenneth know full well, if we look at some of the history we have with just our linting for Ansible and GitHub, we repeatedly have to fix the linter because newer versions of the linter or newer versions of the actions or something require intervention. There is actually a full-on job to keep the automation running. Yes, it reduces workload and it makes it clearly the right thing to do, but it is not fire and forget. You don't do it once and then you don't look at it for 6 months, because you try that, then you have to remember what you did, and it's really, really hard to get it working again. Monitoring is hard. Reporting is even harder. You need to figure out exactly how to do that. And testing and production, no matter how hard you try, they're never gonna, they might be similar, but they're never gonna be the same. And believe me, the moment you realize they're the same, you have other problems, you just nuked prod. Take it from someone who's done that road. So yeah, infrastructure, a deep dive and a whirlwind tour of what's going on in the EESSI world. Questions?
Yeah, I do have a question. Can you go back to the, you had the slide on Stratum 1s and, yeah, this one. So the reason we're, I should say, think about getting access to all Stratum 1 servers to a dedicated team of people so they can manage those Stratum 1s, or if something goes wrong. So we had an issue at some point where I think the Stratum 1 in Norway was serving an old revision of the repository, and it took us a while to actually figure out what the hell was going on, because we weren't seeing updates, and yeah, it was a bit fishy. So for that kind of reason, we would like to have the public Stratum 1 servers in the EESSI network to be accessible by you, me, well, a couple of core people who pretend to know what they're doing.
I'd like to go even further and say that public Stratum 1 should be managed from a central Ansible configuration and be a completely locked. I mean, they are managed by EESSI. They are not. You can set up something locally on your local resource if you want to and stuff, but when it comes to managing, we have to do it, because, as you said, when things start to go wrong,
yeah, you have to be able to intervene, or at least have a very quick and easy way to kick out that Stratum 1 from your network in one way or another. Now, if you look at what big CVMFS sites do currently, I'm not really seeing that that's what's happening. So it's not like they have a team of people that manage all the Stratum 1s. They just say, look, you can host your Stratum 1, we'll put it in a network, but you better make sure you keep it up to date, you monitor it and all these things. And if not, we're just going to kick you out of the network again. So that you're shifting that burden or that responsibility back to the sites. And one of the reasons, like I was quite convinced that we should have our own Stratum 1s, manage them ourselves, and Ansible deploy them so they're all the same and we know what we're getting into. But there's an alternative where, and Dave Dijkstra, so he's a very experienced CVMFS admin who some of the biggest repositories for the CERN experiments. He manages those, that network. And he just said, we'll just add EESSI to our Stratum 1s and you're all over the world in a heartbeat. That's an option as well. And then we don't have to manage our own Stratum 1s anymore. Maybe it's a bit of a risk, but in terms of scale, that's going to be hard to beat. And also in terms of experience of keeping these things running and monitored and having people that can actually fix them. We're shoving it off to someone else. There's downsides there, but there's benefits as well.
Oh, there's huge benefits for it. The main downside is, like the suggestion previously, what if we want to move to S3 as a backend?
Yeah.
You know, what if I don't foresee there being any complications with having conversations with the CVMFS people. I don't think that's going to be a problem at all. And the only thing I would say is that if we allow people to come in and hook up their Stratum 1s, and we just say we kick you out if it doesn't work, we need to automate that kick out. Like if you haven't had an update for, say, 24 hours, we remove you automatically from the pool. because the big issue I have is we're shipping software that runs on people's machines. And if they're connecting to a Stratum 1 that we don't have control over, that provides software that we no longer see as being consistent with what we're serving, I don't know if that's a security threat. I don't know if that's just old stuff. I don't know if, they saw a patch coming into the compat layer that they didn't want because their admin thought, oh, this fixes a backdoor that somebody here was having fun with. I mean,
and in some sense, it's also a constraint, right? Because if our requirement is going to be like, if you want to be a Stratum 1 in the public EESSI network, you'll need to give us full access to that VM or server or whatever it is. For Stratum 1s hosted at HPC sites, very likely the answer there is going to be a hard no. Like, this is just not going to happen.
But I mean,
we're not going to give you admin access to any VMs in our network, which makes sense.
Yeah, but there's also a difference between offering a public Stratum 1 and a private Stratum 1. If you're a HPC cluster in Norway, you might have a private Stratum 1.
Yeah.
And
fully self-managed.
If you ship old stuff to your people, the only thing I do care about, and this is purely from a long-term, EESSI hat on my head thing, is that I don't want EESSI to be known from its users by delivering subpar services from a third party. If they're delivering crap and it's not working, people might just stop using it from that site, and then go, okay, I'm not going to use it on my laptop. I'm not going to use it anywhere else. And there is a certain, there's a possibility that we will encounter this problem where we suddenly fall off and say, oh, well, we're losing trust because because other people are providing a lesser service than they should be, even though we are, offering the tools to do it right. There are conversations like that we definitely need to have, and I don't think we're going to have a solution to that here and now, but it is something we definitely need to think about. And I think to begin with, at least, I think whether or not we host our own Stratum servers or proxies or whatnot, I think the way of managing nodes and deploying them from an infrastructure point of view, I think that's a give that we have to be able to spin up a Stratum 1 that actually works in an automated fashion.
Yeah.